The people who restore these boats, they pour their whole heart and soul into these projects. What we're here for is to support them in that project and to also make their visions come true and to show them what's achievable. My name is Adam Langerman. My company is Langerman Design, and we're a naval architecture and marine engineering company with a focus on classic yachts and modern classic yachts. And we support the marine industry by making custom parts for custom boats. The reason we set up this machine shop was to support the unique parts we require. Being so involved in the design side, by integrating the manufacturing process, we also basically get one extra loop around the design cycle in the manufacturing process. So when we're setting up to make a part, we get to have a final reevaluation of that part and make minor changes that might not be groundbreaking, but certainly are always taking the part to the next level. On the mill, we've got a mast step plate, and we're just actually on the back side of it, and we're going to be counterboring some holes that were already bored through the front side. We're going to use the probe to get each hole and counterbore each hole independently, and that way we don't have to worry about the plate being in a certain spot on the table. On the lathe today, we're going to do we're calling it a drive screw for also for the mast step project, and it basically is used to push or pull the butt of the mast forward and aft to control the rake of the mast in the boat. The drive screw is about 6 inches long. It's got an M20 thread for about 5 inches, and then it's got a octagonal section that a wrench can go to, and that's going to be flattened out with the 4th axis. Probably longest run right now is in the 20 hours for a single part, and that's a lot of 3D milling, probably something on the 4th axis where it's an organic shape that's coming out of a piece of bar. That's one of the challenges we deal with, is we're trying to make brand new parts that look like they were handmade 100 years ago, and the goal is to not be able to tell the difference between the new part and the old part. So a lot goes into the modeling and a lot goes into the programming to get them there. When we spec'd out the mill, we were looking for a Swiss Army knife, and it's definitely proven to be that. It's able to do a lot of different things for us. Between the 4th axis, the probe, and the amount of space on the table, it's really been invaluable in several different types of parts. The lathe is more of a beast. We sized it thinking about what the biggest part we're going to make for our current project is. For the most part, we're underutilizing its capacities, but when we have put big stuff into it, it's just really made it an easy process. My education is in naval architecture and marine engineering. The amount of information that's out there, especially from Haas, made the transition from going from design to manufacturing very smooth and very easy. And that's, I'd say, one of the biggest reasons we ended up with Haas machines is because of the support we've been getting and because of the sort of open book nature of all the information that's available.